Okay, so chapter 9, a lot of it we're going to talk about polynomials. Like I said at the beginning of the chapter, we're going to add, subtract, and multiply polynomials. And then the rest of the chapter, we're going to factor polynomials. So we're just kind of going to break it up and add, subtract, multiply, and then we'll start like a new thing and factor next week. So let's just talk about what a polynomial is. First of all, a polynomial is made up of different monomials. Now, mono means one, okay? So if you're monogamous, that means you only have a relationship with one person, all that stuff. Mono is always mean one. So a monomial is a number or variable or a product of numbers and variables. Now, what does that word product mean? It means they're multiplied, right? So the only operation you see in a monomial is multiplication. There are no pluses and no minuses. All right, the degree of a monomial is the sum of the variable exponents. So that just means you add the exponents on the variables if it's a monomial. So if you don't have any pluses or minuses, you add the degree, the exponents on the variables. So the first one, 4a squared b. You got an a squared and a b to the first power. So 2 plus 1 is, so this one is a degree 3 monomial. So you just add the exponents on the variables. Now look at the next one. 5 is a monomial because it can be a number. Does it have any variables though? No, there's no variables, so it's a degree 0. So if it has no variables, it's a degree 0. And then we have negative 15 next to the fifth, y to the third. What do you think the degree of that monomial is? 8. You add the 5 and the 3 and you get that's a degree 8 monomial. So that's how you get degrees of monomials. And if you have a polynomial, which we have a bunch of monomials added or subtracted together, so we'll see pluses and minuses, the way you get a degree of the polynomial is you find the biggest monomial degree. Okay? So you separate them out, and it's usually your highest exponent, but if you have more than one variable, it's your highest degree. So this monomial is a square, right? It's a degree 2. This one has just an x, it's a degree 1. And this one doesn't have any variables, so it's a 0. So what's a bigger one, 2, 1, or 0? 2. So if they're added or subtracted together, the whole polynomial takes on the degree of the highest exponent. So this is the degree 2 polynomial. And the polynomial below it has 4 terms. What's the highest exponent we see? There's an x to the 5th power, right? So it's a degree 5 polynomial. So if it's a polynomial, you take the highest exponent. If it's a monomial, you add them together. All right, here's some more terms for us. I'm going to give you a second to write those down before I talk about them. What is a coefficient? Any coefficient. What's a coefficient? Nobody knows what a coefficient is? Have you heard the word before? Okay. Y'all, a coefficient is the number in front of a variable. So it's the number that gets multiplied by the variable. So if I have the monomial 2x, the 2 is the coefficient. Okay? So it's just a number that goes with the variable. But a leading coefficient is if we have our polynomial arranged by the degree, then it would be the leading term in front of the first variable. Okay, so it's a term in front of the first variable of a polynomial after we put it in decreasing order. If you hear me say descending and decreasing, it's the same thing. It goes highest to lowest, is what that means. A binomial is a polynomial with how many terms? 2, like a bicycle has 2 wheels. And a trinomial is a polynomial with 3 terms. Tri means 3. Got it? All right. So the first thing we're going to do is rewrite a polynomial in decreasing order. Now, if it says decreasing or descending, like I said, those words mean the same thing. It means highest to lowest exponent. Highest to lowest exponents. So what we're doing here is we're just rearranging the polynomial. Now, when we rearrange a polynomial, guys, whatever sign or symbol is in front of that, if it's positive or negative, that still has to be in front of that coefficient. Okay? So problem A says 2x to the third power minus 5x to the fourth power plus 15x minus 6x squared plus 4. That's a big, long 5-term polynomial. So what's the highest exponent we see here? Fourth power. So the leading coefficient is going to be negative 5x to the fourth. And I'm going to underline them as I write them so I don't recopy myself and I don't leave anything out. What is my next highest exponent? The cube. So it's a positive 2x to the third. So I'm going to put plus 2x to the third. What's my next highest exponent? So minus 6x squared. Next highest. Plus 15x. And what's my last one? Plus 4. If it doesn't have a variable, we call that a constant term. So all we're doing is rearranging it so the exponents go highest to lowest. Okay? So when we start adding and subtracting, our answer always needs to be highest to lowest exponent. But look at problem B down there, and you got A's and B's for your variables. How do you think you're going to do highest to lowest exponent when you have A's and B's? You add them together. So this little monomial right here is a degree 3, right? This one right here in the middle is what degree? 4. And this one just has an A. It's degree what? 1. So yeah, if they have more than one variable, you add their exponents to figure out their degree. So which one is the highest then? So negative 2a squared b squared. And then what's the next one? 5ab, and it's positive, so I put a plus. ab squared. And then the last one's plus 7a. So are there any questions about how we rearrange with highest to lowest exponent? Decreasing order or descending order is what it's called. Okay. Now we get to do the fun stuff with the arithmetic. So we're going to start with adding polynomials, and then a little while we'll do subtracting. So section 9.1 is all about adding and subtracting polynomials. Now, I see pluses and minuses in these problems. So how do you think you know if it's an adding problem or a subtracting problem when you see pluses and minuses everywhere? Right. See how the polynomials are separated by, these are actually trinomials because they both have 3 terms, but they have parentheses around them? Okay? You look between the parentheses, and that tells you what you're doing. Now, if you're just adding, don't make it hard on yourself. If you're just adding, all you're going to do is combine your like terms in decreasing order or descending order. Okay? So what is a like term? What, by definition, what is a like term? If they have different exponents, are they like terms? Some say yes, some say no. But are they the same if they have the same exponent? Is there a difference in a number to the third power and a number squared? A big difference, right? And x is just an unknown number, right? So like terms have to have the same variables and same exponents. You need to know that. Like terms have same variables and same exponents. So you already know an x and a y are not like terms, right? Also, a constant can only be like terms with other constants. Now, constants, remember, are the terms that don't have variables, okay? So you can't combine a 5 and an x because you don't know what x is. So same thing with x to the third. You can only combine x to the thirds with x to the thirds. You can only combine x squares with x squares. You can only combine an xy with an xy, not an x squared y. Okay? Exact same variables with exact same exponents. So what's my highest exponents I see right here on this problem? X to the third power. So the first thing we're going to do is combine those. And when you combine, you add or subtract the coefficients, and you go by the signs in front of the coefficients. So what is 2x to the third power plus 1x to the third power? 3x to the third. We don't change the exponent when we combine like terms. Never change your exponent when you're just combining like terms. And then what's my next highest exponent, y'all? X squared. So I have a negative 5x squared plus 2x squared. What is negative 5x squared plus 2x squared? So I put minus 3x squared. And then what's the next highest exponent? X to the first power, just x, right? Is there any others beside that one? No. So you just bring it down. If it doesn't have a like term, you just copy it when you get to it. And then what do we put on the end? Minus 1, the constant. So this is my answer. Highest to lowest exponents, combine like terms, and when you combine like terms, you don't change your exponent on your variables. All right, look at problem D. We're still adding the two polynomials. And when you add the two polynomials, you combine like terms. And we do it in decreasing order. So what is my highest exponent I see in this problem? X squared. So what's 3x squared plus x squared? 4x squared. And then what's my next highest x's? Positive x plus 4x. What's positive 1x plus 4x? So plus 5x. And then what do we do? The constants, negative 6 plus 10 is what? Positive or negative 4. So I put a plus. Any questions? Why don't y'all try the next one on your own? See if you can. Oh, this has something funky happen. Y'all see what's funky going to happen here? The ones with the third exponent are going to cancel out because that's a negative 3 or negative 1x to the third and a positive 1x to the squared. And I added them together. What do I get? 0x to the third, and 0x to the third is 0, because 0 times anything is 0. So those cancel out. So if they have opposite coefficients but the same variable, they cancel out. So y'all combine the rest of them real quick and see what you get. Y'all understand why the x to the third power is canceled out? Because when I add them, I get 0. Okay, so what did you get when you combined your x squares? 1x squared, so just x squared would be fine. If you put a 1 there, that's okay. And I like to underline them as I go so I don't leave anything out. Then what's next? It doesn't have a like term, buddy, so you copy it, and then same thing with minus 12. So raise your hand if you got x squared plus 3x minus 12 for the rest of that problem. Any questions? All right, we're going to skip these u-tries, and we're going to go to subtracting. Subtracting is just like adding, but you got one more step to do first. So subtracting is very similar to adding. You just got one more step to do. And it's the step at the very beginning. So you look between the parentheses of the two polynomials and you see a minus sign. The first thing I want you to do is stick a 1 between that parentheses and the minus sign. Because what you're going to do to subtract polynomials is you're going to distribute a negative 1 times everything in the second polynomial. Okay? So distribute a negative 1 to every single term in the second polynomial. The first polynomial is not going to change. So I'm going to let y'all copy for another second. What happens when we multiply something times negative 1? It changes your sign from negative to positive or positive to negative, right? So you don't have to think too hard at all when you're multiplying times negative 1. You just change whatever sign is in front of that coefficient. So the first parentheses is not going to change. So I'm going to copy 4n squared plus 5. And then everything after that, I'm going to change the sign, and I'm dropping my parentheses as I go through here. So what's negative 1 times negative 2n squared? Positive 2n squared. What's negative 1 times 2n? Negative 2n. And what's negative 1 times negative 4? So I changed all my signs. Now what's my second step? Like terms in decreasing order or descending order. So what's my highest exponents I have with my n's? N squared. So combine my n squares. I have 6n squared, or I just said what it was. 4n squared plus 2n squared is what? 6n squared. And then what comes next? And it doesn't have any friends, so I just copy it. And then what goes last? Positive 5 plus 4 is what? Plus 9. So there's my final answer. So you're done when you have no more like terms and your exponents go highest to lowest. Copy down the next problem, please. So you look between the parentheses, and what sign do we see between the parentheses? Subtraction sign, a minus sign. So what do we do if we're subtracting polynomials? What's the first thing we do? Distribute a -1 to the second polynomial, which means we do what to the second polynomial? Change all their signs. So what are we going to do to the first polynomial? Copy it, just like it says. And the second polynomial, we're changing all the signs. So that's going to become a -3x squared. And then what else? Positive x and a what? Positive 8. Change all the signs in the second polynomial. And what's my last step? Like terms. What comes first? X squared. So what's 4x squared minus 3x squared? 1x squared. So you just put x squared. Then what do you combine? -3x plus 1x is -2x. And then what's the last thing you combine? Positive 8 or positive 5, positive 8. Add those and get what? Questions? So subtraction just has one more step than addition. We're going to skip this one. Let's do this J because the variables are different. Those are A's and B's, not 6's. So sometimes the same problem gives you more than one variable. Question. Is an a squared b a like term with an ab squared? No. The variables have to have the same exponents in the same spot. Okay? So they got to have the same exponents with the same variable. But an a squared b is like terms with an a squared b, though, right? Yeah. Because the square is on the a and the b is to the first power. So is this an adding or subtracting problem? Subtracting. And so what do we do first when it's a subtracting problem? Distribute -1 to the second parentheses. So what do we do with the first polynomial? Copy it. And then what do we do with the second one? Change all the signs. So you'll tell me what I'm going to get when I change all my signs. And then K minus A. Now, which ones of these terms do you think have the highest degree? The a squared b's, okay? And we got two of those, right? So those need to come front. So what is 5a squared b minus 12a squared b? Okay. And then what do you think we're going to do next? Good. Positive 2ab plus 4ab is what? Positive 6ab. And the last two only they have one each. And then I like to, and your book usually does this, put them in alphabetical order. So if they tie, I guess you would say, for their degree, I would put them in alphabetical order. So I'm going to say minus A, minus 4B. And I think that's how your book does them. So that way we're just consistent with you checking yourself in the back of the book so it won't confuse you. So if they're the same degree and you have a different arrangement for those, I'm good. Does that make sense? So it's not going to hurt my feelings if you put B before A. I'm not going to count off of that because they're technically tie, right? All right. Y'all try that one. Check your answer with a neighbor when you're finished, please. All right, so what do I do first if I'm subtracting a polynomial? Yes, so I copy the first one. And then what do I get when I change signs? And then, good, everybody do that? And then what do? Like terms, what's my highest exponents? X squared. So I've got 4x squared minus 5x squared, and that gives me what? Negative 1x squared. And then what? Yeah, negative 7x minus 4x is negative 11x. Am I done? What do I put? So raise your hand if you got that for your answer. Any questions? All right. I want to show you one more thing for addition and subtraction. So this lovely little triangle here asks us to find the perimeter. How do you find a perimeter of an object? You add all the sides. Perimeter is your distance around something. So you add all the sides. So these sides are all binomials, aren't they? They're all binomials. So I'm going to write out my binomials. 2x plus 1 plus 5x minus 4 plus x plus 7. Now, if you write yours out in a different order than me, that's okay, because addition is commutative. That means you can reverse the order in which you do it and still get the correct answer. So then I can combine all my x's and combine all my constants, right? So what is 2 plus 5 plus x? 2x plus 5x plus 1x. 8x. And then I have 1 minus 4 plus 7. 1 minus 4 is negative 3, and negative 3 plus 7 is positive 4. And they didn't tell me any units, but we know perimeter needs units, so we're just going to say units. So any questions on how we do if they give you a shape and you have to find the perimeter? Can y'all add up all the sides? Combine like terms? Y'all are awesome. So that's the end of adding and subtracting. So we're going to start section 9.2, which is multiplying. Let's think back to chapter 8, which we just took a test on yesterday that I haven't graded yet. I'll do it ASAP. I'm like halfway through. If we multiply two variables with the same base, we have to do what? Add the exponents. Let's not forget that. Okay? If we multiply two x's together, we add their exponents. Right? Right? Okay. So that's what's going to happen with our variables. Now, what this is right here to start with is a monomial times a polynomial. Monomial, because it don't have any pluses or minuses, times another polynomial. Now, what does it look like? It looks like distributive property because it is distributive property. Okay? So we're just going to distribute. We're going to multiply our two coefficients together, and we're going to add our exponents for the x's. Because when you multiply two things with the same base, you add them. Now, when you're combining like terms, do we add exponents? No, because that's adding and subtracting. But when we multiply polynomials, we do add the exponents because that's what the exponent rule is for multiplying. So what is, okay, 2x to the third times 1x to the third. 2 times 1 is, and x to the third times x to the third is x to the 6. So my first term is 2x to the 6th power. Then I do my second term in the polynomial. 2 times 3 is 6, and x to the third times x squared is x to the 5th. Y'all with me? All right. 2 times negative 2 is what? Negative 4. And x to the third times x is what? X to the 4th. And 2 times 5 is 10. And it don't have an x, so you keep the one you got over there, x to the third. And we have all different variables with different, or same variable, different exponents, so no more like terms. They're in order already. So that's my answer. Just distribute. Multiply your coefficients together, add your exponents. Any questions about that one? Just rearrange them. All right, look at B. What are we going to do on B? We're distributing. Yeah. So we're going to multiply negative 3 times all of our numbers and x squared times all my x's. So what's negative 3 times 2? Negative 6. And what's x squared times x to the third? 2 plus 3 is 5, kindergartners. All right, then I have what's negative 3 times negative 1? Positive 3, and x squared times x squared is x to the 4th. So plus 3x to the 4th. All right, what's negative 3 times 4? And what's x squared times x? So it's negative 12x to the third. And then I do my last one. What's negative 3 times negative 3? Positive 9, and we keep the x squared. So plus 9x squared. Any questions? Now look how little and simple C looks. But don't let that make you feel all big and bad, because sometimes we can do the big long ones, and with the little easy ones we mess up on, okay? So what do you think is x times 4x? 4x squared, isn't it? Yeah. So we get so caught up on learning how to do the big ones, sometimes we forget how to do the little ones. And what's x times negative 2? Negative 2x. So this one's just 4x squared minus 2x. Any questions? All right, and then we're going to add in another variable. This one has x's and y's. Now, when we combine variables, we can only add exponents if they have the same base, right? So we're going to add x's with x's and y's with y's. And we're still distributing. We're going to multiply 2x squared y times everything. So when y'all get that copy down, look up at me. Good morning. All right. So what's 2 times negative 4? Negative 8. What's x squared times x? X to the third. And what's y times y squared? Y to the third. And that's our first term. So any questions about how we did the first term? All right, you just do it one variable at a time, okay? So what's negative 3 times 2? Negative 6. And then we have an x squared times x, and get what? X to the third. And this one doesn't have a y, so we just use their y. So it's x to the third y. Any questions on the middle term? And then we do 2 times 5 is what? 10. That one has an x, this one doesn't, so copy the x squared. And then what's y times y to the third? Y to the fourth. And those are really not in order by degree, but if there's more than one exponent, I don't really care. So, or more than one variable, I really don't care. So any questions about that? I want you guys to try this one. That's a 5. It looks crazy. It's a 5. Go ahead and check your work with the neighbor. All right, y'all help me work it, please. What did you get when you multiplied 2x squared times negative x squared? Negative 2x to the fourth. Everybody good on that one? So what did you get when you multiplied 2x squared times 5x? 10x to the third power. Very good. And what did you get for 2x squared times negative 1? Yeah, it just changed the sign, didn't it? So negative 2x squared. So raise your hand if you got that for your polynomial. Any questions on adding, subtracting, and the multiplying parts that we have done? When do you distribute a negative 1 to everything? When you're subtracting polynomials. Okay, that's the end of this lesson. I'm going to stop my recording. Goodbye.